Awesome. Okay, so hi everybody. Now you cannot see me right now, but that's okay. Welcome to the Data Science Week 2024. So as you know, it is an event which is ongoing since a few years. We have today the first presentation, but before that, I will just give some details about the schedule. So we have one talk today. Tomorrow we will have a second talk and a couple of workshops in data science for biological sciences and data-driven dynamical systems. We have on Wednesday a talk on topological data analysis of spatial systems. Again, the workshop on Thursday, and a documentary called Thinking Game. You're very welcome to follow it. You will receive information about that. Then Friday we will have the last panel discussion and poster and talk awards. If you want to read more about the speakers, you can find information on the website. There is also poster and short talk already available, and you have information on the members of the panel for Friday. You can see all of them here. And if you want to play it, you can connect to the Slack chat and Gather Town. And in Gather Town, if you're not familiar with that, it's a 2D environment where you can go around, talk to people, look at the posters, look at the short talk, and write on blackboards as well. So now I'll stop sharing. Okay, and I will introduce Professor Lin, who is the first speaker of Data Science Week 2024. So Dr. Lin is a distinguished professor of statistics at Purdue. He served as department chair from 2020 to 2022. Before that, he was a distinguished professor of supply chain management and statistics at Penn State, where he worked for 25 years. So his research is in data quality, industrial statistics, statistical inference, and data science. He published about 300 papers in journals and conferences. He serves as an associate editor in more than 10 professional journals, and is co-editor for Applied Stochastics, Models for Business and Industry. And actually, previous editor-in-chief Fabrizio Ruggeri is from the city I did my undergraduate. Dr. Lin is elected fellow of ASA, IMS, ASQ, RSS, elected member of ISI, elected member of ICSA. He's an honorary chair professor of Harvard University, including Chang Yang Scholar at Renmin University of China, Pudong University, National Taiwan Normal University. His recent awards include the Uden Address ASQ 2010, the Shewell Award ASQ 2010, the Donovan Award SAA 2011, the Lottit Address SSC 2011, the Hunter Award ASQ 2014, the Stewart Medal ASQ 2015, and the SPSS Award ASA 2016. He was the Deming Lecturer Award at 2020 JSM. His most recent award is 2022 Distinguished Alumni Award from the National Tsinghua University in Taiwan. So it's obviously a great pleasure to have Professor Lin here. And without stealing more time from him, I will start his presentation. So thanks a lot for being here today.
Yep, thank you. Let me share my slide. I forgot about this. Let me try it again. Stop, share, and then advance, share audio. Okay, next, share. And open that. You see my slide all right?
Very well.
Okay.
Maybe they're a little bit large. Maybe they're a little bit large, but I might be able to. Okay, no, I can adjust that.
Okay. First of all, hope everybody had a wonderful Thanksgiving break. I do a lot of things thankful, especially for Atlanta. Thank you so much for the kind invitation to join this such a wonderful workshop. I regret I cannot go there in person, but really sincere. I watched the program. It looks wonderful. Hope we can keep moving around. All right. Okay. This is the abstract I post. I'll come back to the abstract later. All right. Well, something I'm very proud of is my family. Lots of things thanks for. So every talk I like to share what's updates for my family. Early this year, when my family come with me, since last year, I become a grandpa now. So all my energy now, I try to impress this young gentleman. I'm working very hard on that. Hope that being successful. Anyway, all right. So when you go to vision test, the doctor asks you A or B. I'm going to try the here. Left hand side is A, right hand side is B. Which one will you choose? I'll come back to this slide later at the end of my talk, and hopefully by then you'll different answer for me, right? A or B, fake or real? Well, hopefully you'll share with me. I would like to choose real over fake. Artificial versus natural. Well, it depends on what you have, but typically I think you probably prefer natural more than artificial. Next one's harder. Artificial intelligence and natural intelligence, which I cannot call them natural intelligence because the name being occupied. I choose the word biological intelligence. Try to be as specific as possible, meaning everything cut by natures, including human intelligence. So you're going to choose artificial intelligence or biological intelligence. Well, it's hard to bid which is which. The conclusion I would like to convince you is you probably need both. And that's my conclusion at the end. AI need also machine and algorithm. Or BI need almost nothing. They only need an instrument, right? AI need also hardware and software. Or BI needs something called hardware. It's not my term. That's from Waco or from City University. Even some mercy, some love. That's about hardware, right? And hardware and software. It's AI and BI. AI need a super big input to make it work. Or BI need very little input or even no input. They know what they're doing for some reason. When a baby bird, the mother kick the bird out from the high tree, but before landing, the bird can fly.
We can't see the slides well anymore. I think that the slides got a little like zoomed in.
Oh. So what should I do?
And we cannot hear you either for some reason.
I got a frame.
Yeah, that's not me.
Is that better?
So it's not me. Yeah, better. A little bit more. Yeah, maybe slightly more.
Okay. That's the maximum I can do. Potion. Oh, you see you're sharing a portion of the screen.
Probably just one.
Share.
It's more or less okay, I think. But we don't hear him anymore for some reason. Right?
Which is the volume control that we had.
Yeah, but for some reason I can't find it anymore.
So what do you see now?
About that tab down at the bottom, one of the on the taskbar. It's the black square with the infinite, no, the black square of the infinite that has tab open already. Yeah, just scroll over.
I think it was the problem with his. Do you mind trying talking again?
Should I stop and over again?
We don't hear you.
Hello?
I'm okay with
Stop the screen. Would that help?
Okay, now just hear it again, which is good. But we just don't have the audio.
Here. What about opening that?
Yes.
What is that? Left. That left. That's that left.
Okay, tell me what should I do?
It's not that.
This one.
That.
This one.
Hover over it. What about that? What's that?
Yeah, but that's one doesn't.
Oh, okay.
Yeah, let's try again the audio. Okay. For some reason, okay, now try again.
Try.
Perfect. We can hear you again. Sorry for the inconvenience.
Oh, that's okay, as long as fixed.
You didn't save the volume settings.
Good, thank you. Okay, yes, please.
It's okay now?
Yeah, perfect.
Okay, great. So my last few minutes try to tell you the comparison between AI and BI. And what I like to talk about today actually is based on my personal profession. I'd like to introduce something called Statistical Intelligence, SI. And I'll argue that SI is something between AI and BI. Well, SI needs some data, but not as big as AI. The BI probably don't need data, but SI also need analysis. So SI, which I'm going to spend more time about that, is some kind of combination between AI and BI and its own discipline to make this work, right? And that's kind of thing I like to communicate with you today. Okay, let me starting with some very simple questions. I think different disciplines have different problem-solving skills. I think so. Only 40 minutes, right? Let me skip this example, maybe easier. Let me starting with second example. I think different discipline have different way to think about this. All right. Well, there's something called input. There's something called output. From input to output, there's something called system to make it happen. When the input goes through the system, we could get your output. The theory behind the system, we call that law of Mother Nature. So there are 4 items right here. You've got 3 of them, and looking for number 4 of them, the 4th. For example, you got input and output, and you try to find system. You got input, output, you got system. You try to find a law. We call that science. When you got input, output, you got law. You try to find system. We call that engineer. So that's basic about engineering science. Let me give you a simple example. If input says grep and output is wine, then the system is actually the brewing process. The law is all the chemical reactions. All right. So look at the bottom line, which I'm going to come back again. If the bottom 2 rows, you've got input, you've got system, you've got output. You try to find law. Basically, this is what in general science try to accomplish. Where you got input, you got output, you got law, and you try to find the system, the best way to make it happen. We call that engineer. Of course, there are all those there are common areas as well, but that's in general, probably general truth. Now, they talk about how to joke into this. If you want to tight 2 forks on the edge of the glasses, for science, you need to find an incredible way to find it. Engineer, you just try to make it happen. All right, simple as that. All right, as what you request, I make it happen. Science, you need to understand a little more detail. Now, in reality nowadays, because of data science, I got input, I got output. I don't have system. If I got system, I find law. That's science. If I got law, I want to find system. That's engineer. But I have none of them. I have input, I have output. I got lots of input data, got lots of output data. And the problem come to us is now we need to do something about it. All right. So first thing you probably think about is building a model. Building model, what depends on what discipline you came from. You came from mathematics, partial differential equation is probably the model you have in mind. If you came from deep learning, probably artificial neural network or deep learning model is what you need. You came from statistics, probably regression model is what you need. You came from human resource, maybe all kind of flow chart is what you need. Depends on what discipline you came from. They have different approach. It's not necessarily who is more winning than the others. It's just different discipline. And I need to emphasize that deep learning is the youngest among all those. Some been 100, even 1,000 years. All right. Deep learning is probably what 50 or 70 years old. All right. So all I'm trying to tell you, models. When you say model, it depends on who you're talking to. It can mean lots of things. Now, once I build a model, whatever model is, so suppose you use a large language model, whatever the model is built, then it comes to science and engineer. If you treat the model as the system and try to find a law behind that, I will call it data science. If you treat the model as a system and try to find a law, kind of called science, data science. On the other hand, if I treat the model as a law, try to find application, I want to call it data engineering, right? I want to separate the distinction between data science and data engineering. Okay, of course, my advisor, George Box, just say all model wrong, some are useful. A large language model, of course, no exception. Model is model. All right. Now, in general, about the science and computer science, I think there's a little bit fundamental difference. Science tends to be science research in science is more like building a brick, building a block. You want to make sure they are correct, solid, concrete before you put it in, because otherwise, in the future, everything going to pile up. All right. So only smart people can do top mathematics. And whether it's a good idea, well, time will tell. When will this get used? We don't know. We don't care. Maybe 50 years later, maybe 100 years later, maybe never. Right? Engineers, especially computer scientists, is different. They want to participate. They propose ideas. Right? Now, whether it's concrete or not, well, time will tell. I see quite difference here. So basically, let me summarize quickly. Computer science, if the idea is good, interesting, it deserves publication. And whether it's correct or not, it's author's responsibility. It's not the journal's responsibility. Right? Which method was really good, correct? Well, time will tell. They want to be inspired. But mathematics, just on the other way, they want to correct. So it must be correct to be published. When ideas, interest, useful, well, time will tell. They want to be correct somehow. And therefore, it reflects to the review systems. A paper go to mathematics journal typically takes about 2 or 3 years to get published. A paper go to computer scientists, it probably take 2 to 3 months to get published. There's nothing about right or wrong, it's just different culture, different way to look at the problem. And because the reward system looks like that, more and more statistics move from mathematics to computer scientists. So it's industrial engineering profession. I think we need both somehow. We need some solid thing. We also need something quick ideas. This long term, when especially in academia, when tenure process coming, things to need for you to debate about that. Some papers just take time to publish. It's not quantity, it's quality that really matter. All right. So the main concern, my focus today for AI is a little bit different from most of you, I suppose. I'm talking about the training data. Okay. And I'll come back to this page. After all, not so informative input likely result in not so intelligent AI. So input data is everywhere. I'm going to go through this page line by line with you, but let me go explain what I'm trying to say to begin with. All input data is probably the key thing. Now, not many people talk about this, at least when I travel over the world, but I'm quite nervous about this, about the training data. You have to understand English culture is still the dominant AI word. So they use their own culture to train the program, their culture, their belief. And therefore, different culture, different philosophies, certain result different things. So in the training set, you don't see much Indian culture, Egypt, Persia, Russia, Chinese, and so forth. All right. And when they're training the AI using their own data, their own culture, you're going to lead into different thinking process. So that's something bothered me a little bit. Well, this is just for fun. I think the more I look at history, more like model fitting in statistical, in other words. History is more like those people who exist in evidence, they try to make a story as complete as possible. Same thing like model fitting. You have available data, some come with errors. You want to fit a model to fit all the data as close as possible. It's more, to me, more like making history somehow. All right. So first concept, very trivial for statistics, but apparently been abused, which I don't like very much, is sample versus population. All right. A super large sample is not population. All right. A good sample is the one who can well represent the population, which may not relate sample size. I'm going to give you an example in a second. All right. The common misunderstanding many AI people believe is when sample size is large enough, it will be the population. It's not. All right. Let me show you 2 examples. So if you'd like to know the this soup, good or bad, you don't need to drink them all. All you need to take 1 spoon, stir uniformly, and take 1 sample size. You will know how good the soup is. Sample size equal 1 is good. When you try to test 1,000-layer cake, sample size 1 is not enough. But if you only sample the first layer, even median sample is not enough. You get a well-represented data, not the sample size. And huge, super large sample size that is not population. Depends on how you sample it. The question really is whether your sample represents the population. And I have a group student who work on this, try to test how good my sample represents population. Okay. The second concept I want to talk about is data are right versus right data. Okay. Data are right is what the AI people are doing that now. They collect data is given, and what can take data tell us from there, and what kind of information we get there. Assume data quality is good. We do lots of data cleaning to make sure data are right. Well, will that solve your problem? That might solve lots of problems. I don't know, but that may not solve your problem. To solve your problem, you need to get right data. Problems given, and what kind of problem we want to solve, and then collect the right data to solve your own problem. Now the data are right, right? So let's give this. There's a book by one of the greatest mathematicians, George Paulier. The book name is How to Solve It, back to 1945. The book is still popular. They taught you how to define the problem in the correct way. There's another article I strongly encourage you to read. It's called Problem Framing. Define a problem and then find the right data. So in quick, data are right. You collect data, all kind of data just in case, and then spend billion dollars to data clean to make sure data quality. Will the clean data solve your problem? Unlikely. They can do model computation. They can do lots of things. They may find some discovery, fun thing to surprise you, but will that solve your own problem? Probably not. To solve your own problem, what you need is the right data. Given the problem, find the root cause of the problem, collect the right data to solve your own problem. The size could be large, could be small. All right. There are lots of intelligent data collection methods being proposed over there. Apparently, quite limited to statistical discipline. But I was hoping more people can get involved with this. Okay. So there are so many people in the world. Did you marry Mr. Right? Right, or Mrs. So it depends on how you call it. All right. Same thing. There are so many data in the world. Did you find the right data to solve your own problem? Now the data are right. What you need is the right data. Okay. Let me add one more word. To marry Mr. Right, you need strategy. To collect right data, you need statistics, especially something called design of experiment. That help you to collect the right data to solve your own problem. All right. Now, criterion for right data proposed by Tom Redman and Roger Hurrell must be relevant, must be complete, must be unbiased, must be timeless. Those are things that you need to match. We try to formulate in mathematical form. Give me a few more years, I should be able to give you something. Okay. So long term, I like to say for real estate, they talk about location for the price for the house. But nowadays, the problem, of course, is data, especially good data and right data. All right. And in statistics, we provide lots of collect data, sampling survey, design experiment, important sampling, census, and many other intelligent data collection methods all exist in statistical literature, but need to be promoted somehow. All right. Coming to training data, I showed you data quality. All right. You collect data very slowly and then using smart data cleaning to guarantee the data are right. Or you just collect data at the very beginning, first stage. Think carefully before you collect what data you have. Sample versus population. Big sample is not population. What you need is a well-represented population to solve your problem. I'll give you 2 examples. Soup taste and cake taste. 1,000-layer cake. Okay. Training bias. Lots of culture is English relevant. and that really worried me a little bit. Your AI will be in English culture background. Okay, this is, I'm not sure how to say this in a good way, so I'll put that interpolation and extrapolation. Mathematician, like mathematician, when they about 95% complete, they don't go to public because they worry there was still 5% unsolved. Well, AI people, when they're 40 or even 20% complete, they go to public, go to press, and tell people how wonderful this. Under the Web Protect umbrella, they can do incredible things, but they never guarantee anything outside the umbrella. And they don't guarantee. So you see lots of announcement from AI. You don't see much announcement from statistics mathematics. Not because they're not working hard, it's just different culture. Right? And the final thing I want to talk about is this concept about right data and data right. And those are things I hope I can share with you what my concern is about AI. Not really the technical part, but the data, the input data. A few more words about that. Learning is not only learning from data. Learning may learn from many ways. But even for data, we have different type of data. AI people tend to use digitalized data. More and more items will be digitalized. And therefore AI will be stronger and stronger. Right? BI, they must have data. We just don't know how to measure that yet. Okay? You see two cars crush each other on the street all the time. But when there are a million birds in the sky, they fly together, they don't hit each other. They must have some way to communicate. Some data they have. We call that soft data because we don't know what it is. We don't know how to measure that yet. And there are so many soft data in the world, we're still on discovery. All right? Well, SI, statistics, somehow our data are more structurized. So we can do some analysis. Okay? And of course, BI is different from AI because they don't look at data. They only look at data in different way. It's looking at different data. Right? This is true for SI as well. Okay. Now, I don't think I have time to go through history of AI. I don't have time to go. I'm going to say a few words about SI, Statistical Intelligence. But when we talk about history of BI, when you're born, you have it. Right? You may talk about how AI developed through calculation to go through programming, and SI from government statistic to collecting text, counting how many people, population, and so forth. But for BI, when you're born, you have it. It's not quite history about BI, but somebody correct me that there's something called genetic memory, which is outside my area. So I don't argue with you. Anybody interested in this, you can go to the other direction. They believe human being or all the animal, when you go from one generation to another generation, their genetic memory is something. That's beyond my ability to explain. All right. So computer science, if you think about computer science, starting from 1623 about mechanical. I see some typing. Well, I'll answer some question at the end. Mechanical calculation to programmable mechanical calculation to IBM to lots of program. The first CS degree program was founded in 1953 in University of Cambridge. The first US computer science degree in USA is from a place I know very well called Purdue University in 1962. I think Purdue computer science is still one of the best program today. All right, I can go through ChatGPT to give you some funny thing. I'll come back to this page later for some comparison. All right, for AI, you can go to Wikipedia as well. SI and SI, you can BI, you can do something as well. You can go through that. I'll skip that today. I'll give it, for example, when I was a young child, when my grandson began to walk, I wonder what kind of training they have. They didn't go to any show course, but when muscles ready, they're ready to walk somehow. We never teach them how to work. And this bird I told you, right? When you kick out from the tree, somehow before landing, they fly. Well, some unusual case happen, disasters happen, but most of birds just can fly. This Boston Power, their research is about how to make a machine walk, robot walk. And last year they bankrupt. So apparently training robot to walk is not easy. But for BI, this seems trivial, right? I can take any lots of exception if you like to, but this is a very general observation. And there are lots of things about biological intelligence we don't know. If those people like me work on optimization area, we got lots of algorithm using animal's name. Apparently there's something we need to learn, right? POS like swarm, right? Genetic algorithm use genetic, and bee, right? Wolf, all kind of animal intelligence. We just don't know much about them yet, right? Statistic, sorry, use Chinese, but that's in 390 BC. Ralph White said a strong nation needs to know 13 numbers. Those numbers are not real numbers, those are just statistics. How many people you have, population, how many land you have, how many rice, how many product you have, how many horses, cow you have, and so forth. All right. So the word statistic in English also means information about the state. So both ways you can say no, statistic originally came from government because government needed, right? And it comes with very basic concept. You formulate a problem and set up the hypothesis. And then you collect data, use data collection method to find the right data. And then you do statistical inference based on the right data to test your hypothesis. All right. And then after test the hypothesis, you generate a new hypothesis and keep looping. Everything, every step, a very solid mathematical theoretical foundation there. All right. It's not by simulation, hey, this looks good. By simulation, this looks nice. It's really very solid. Every step have fully proved through years. And they are apparently through a year because the data, they change now. We just need to learn probability before we learn statistics. Nowadays, you probably don't need probability. Lots of data is more data driven than probability driven now. I still think probability is important, but somehow it's not as dominant as in the past. Those people don't know much about probability. You still can do good statistics with data. Big data. I hope you heard about the big data before. But have you heard big data last few years, especially last 2 years? Where's big data now? All right. They told me about 7 or 8 years ago, they told me big data are going to be all over the world. Everybody need big data. In the future, everything is about big data. But it just disappeared now. All right. I can tell you my own experience. When I get my degree a long time ago, AI was there. But then something called artificial neural network become very popular. They're going to dominate the world. Everybody think artificial neural network will be in the future. Then everything called data mining now. We talk about data mining here, there. We go to lots of conferences. Everybody talk about data mining. Then it disappear. Now big data coming, deep learning coming, Internet of Things coming. All right. We don't mention that much now. Everything is AI now, data science. Okay. Those are different from mathematics. They never change name. Statistics, they never change name. Chemistry, they never change name. So it came from culture of science. We don't like this culture, but computer science is like everything built up on top from one from the other. All right. The warning I'm going to give to you is, how do you know when AI will be replaced by some fancy word very soon? We don't know. Nothing wrong with it. All right. Another thing I have to mind that I've been changed quite a bit, changed by ChatGPT. But before ChatGPT, apart from more efficient, faster, bigger, better, was a breakthrough application for AI. Cell phone change your life. Okay, or WeChat or TikTok change your life. But what really AI change your entire life? I'm not sure, because anybody can comment on this. I have to say ChatGPT may be one of them, but this is not as popular as what you think. All right. So my good friend John Jordan keep talking. He say AI routinely cheat, which is a little bit too much. But let me give you one example to say about this. This is what I believe in public voting 10 most famous formula that change our life, mathematical formula. AI can do calculation 100 billion times faster than you do, but AI cannot write down any single formula here. Those must be by BI, right? Write down the formula. It's probably what we can do, rather than by computing, of course, you cannot beat AI at all, right? To be or not to be, that is the question. That's Shakespeare. Shakespeare write lots of good words. AI cannot invent those sentences, those writing. It must be Shakespeare. All right? Mozart. I was told Mozart to write music. He was 5 years old. Right? Those music can only done by Mozart. Nobody else. Right? Well, of course, it's beautiful as well. Right? Those music can only written by nobody else. Okay? About painting, the famous Van Gogh's, one of his famous painting is called Starry Night.
Starry, starry night. Picture palette blue and gray.
All right. So all those things, so what I'm trying to say was mathematical formula, music, art. They can create work, unlike AI, and AI cannot reproduce them. All right. But what AI can do, if you have lots of unclosed art put into AI, AI can create on your right hand side, AI can create something similar to Van Gogh after reading all the input. All right. So after training, AI can have data farming and reproduce somehow their work. But without those input, AI simply cannot create a brand new work. All right. You may disagree with that. We can talk. All right. But that's the point I try to make. All right. This is an example, not a good example, but it's a good example. On your left hand side, you see wolf. On the right side, you see husky. It looks very similar. Wolf, husky. Right? Then you're feeding all the pictures into AI system. This is wolf, this is husky, this is husky, this is husky, that's a wolf, and so forth. After that, you give them new pictures, say, identify this is wolf or husky. Well, in this particular example, because the training data bias, all the wolf come with snow. So when AI see snow, they will automatically tell you this is wolf right away. If it came from not snow picture, then they'll probably do something else. But that's not what you have in mind when you do classification. But that's where you're training, and AI will find a good way, quick, efficient way to do classification. Right? And depend, you probably don't know what your input data have such pattern, but AI will find out for you. Is that good news or bad news? I don't know. Could be bad news. All right. On your left hand side, you see Chihuahua. On right hand side, you see muffin. Is that clear? All right. Chihuahua, muffin. Muffin is this blueberry muffin is spectral. So it's easy to identify from human being. But for AI, apparently this is very difficult. Okay, if you give them a picture and ask AI which is Chihuahua, which is muffin, apparently they still have time to learn to get the best answer for this. All right. Next example, I can tell you ramen. Ramen, Chinese ramen, Japanese ramen, and Korean ramen are totally different meaning. In Chinese ramen, rao means pull, so you pull the noodle from flour 2 to 4, 4 to 8, and so forth, and getting longer and longer, and very cheap, very popular food in China. It takes about maybe $1 or $2 US. You can get a wonderful Chinese ramen in China. Japan ramen is an art, right? You probably need about what, 5 or 10 US to get a reasonable Japanese ramen. It's art. It's not cheap food. Korean ramen actually is instant noodle. You can buy from the supermarket and go home, put some hot water. So I'm curious about if AI first time hear the word ramen, which ramen AI have in mind? Again, this comes to cultural problem I told you before with the very simple examples. Right? So what AI can do, I cannot do. Well, AI lack of physical sense. They don't have common sense. All right. You cannot, any single person cannot appear in Purdue and Berkeley at the same time. We know that, but AI don't. Lots of common sense. That's not well trained. It's difficult. That's why original meaning back tuning about 1940, 50, when talk about AI, it's difficult because they try to explain those logic, common sense, but common sense is just so difficult to model. The lack of basis for inference, what I told you about a foundation to make decision. All right. The problem is they never tell you which algorithm work, which algorithm won't work, and when. Right. The key point, I think, from my view, AI don't know what they don't know. They don't know what they don't know. That's a key problem. They always give you answers, likely to be good answer, but there's no guarantee. You can ask, you dare to ask, they dare to answer. They don't know what they don't know. And mathematics tells you all problems have boundary problem, and AI just don't have boundary yet. Okay? And fail to define business problem to be solved. Here's the data. Can AI define what problem I want to solve? Right. So even AI can replace you. Will you ask AI to help you? For example, exercise. You bring a robot to gym. Will you ask robot to do exercise for you? Probably not. You still want to do that by yourself. Even AI is capable. Same thing, if you think about it. Do you want to memorize multiple table or very baby calculus by yourself? At least you should have basic understanding. Not for AI to do that for you. Right? It's just like, to me, if you don't know multiple table, you don't know how to add two numbers together, you ask, it's just like you bring a robot to gym and ask robot to do exercise for you. So what is fundamental education we need? And what should we go to AI to help us? That boundary is not clear. And I think that we spend lots of time on education to think about what should leave to AI and what should leave to BI for us to train for our course curriculum. So I think those people work on teaching the courses, design all the new curriculum, need to spend more time on the subject. Okay, so Jordan, my good friend, John Jordan, believe AI is a strong word. He's not sure about artificial intelligence. He even believes there's no intelligence there. It's not AI. It's not no intelligence. It's more like cognitive automation. You got to super input data, and then through the program, they give you some automation result. All right, and output are more statistical approximation. All right, and they lack of common sense. So that's something for you to think about. Do you really want to call that AI? Or you want to change it up to more reasonable name, cognitive automation? Okay, so come back to what portion I have for you at the very beginning, A or B, when I have technical problem. Fake or real? Probably choose real. Artificial or nature? You probably choose nature. AI versus BI. Well, I think you need both. You probably follow my logic. AI need lots of machine and algorithm, but BI need almost nothing. AI need hardware and software, but BI need hardware. AI needs super input data. BI need very little or even no input. AI needs CPU or GPU. BI need IQ. One worst way to measure IQ by GPA, but that's what we're using, unfortunately. In between is what I'm trying to sell you today. It's called SI. SI need to combine AI, need some data, need some calculation, but I also need some BI to make decision. Okay, I call it good well because everything based on SI is fundamental theoretical. They all got a lot of theoretical support. All right. So statistical intelligence comes with good well. And this is something I want to say a few words about this hypothesis testing, which come on misleading. But easy way for me to share with you is when testing on the bottom, when testing hypothesis with the difference equal to 0. I should use D, but anyway, testing some difference equal to 0. And let me remind me a story. And many years ago, I went to Xi'an China, and find a very Asian art, Chinese art. So we debate on the price. And in the end, I asked, how old are these things? How old is this Chinese Asian art? And the manager was very proud, told me this limit. I know it's about 10,003 years ago. I said, wow, so precise. Something in 10,003 years ago. Where the number came from? And the manager told me, you don't know. 3 years ago, this professor come and tell me this is 10,000 years ago. So by now, at 10,003 years now, right? The story I try to tell you is, to statistician, 10,000 and 10,003 is the same number, right? Hopefully you agree with me, right? But for AI, for mathematics, for computer scientists, 10,003 is greater than 10,000. So that's still hypothesis and try to test whether those 3 years, the different 3 is a significant different from 0. If you divide by 1,000, 10,000, probably it is just 0, just random error, right? So those statistical hypothesis testing idea apparently did not implement to many computer science or AI people. 10,000 and 10,003, using common sense, they are same number, but they don't think so. For example, I went to one of the model contexts, and the criterion is mean square error. And you see on the bottom, one team came from mean square error 0.3245638. The other team came from mean square error 0.3245639. It turned out 0.3638 get a champion, $10,000, or 369 get a second place, $5,000. It doesn't make any sense. To me, they are 10,000 and 10,003. They should be same number. All right? So it's the way so-called hypothesis testing tries to test whether the difference is indeed a random error or negligible. And that idea seems to need to be extended a little bit to computer science and AI people. All right? So I showed you this page. I think I run out of my time. I got 2 more minutes to run. So problem formulation, data collection, and very solid. Some concern about AI, legal base for inference, what I told you, 10,000, 10,003, right? Not same thing. Holding this, what I told you about data, original data, and a few new data, right? What problem to be solved, and could be end up with some disaster if you don't care. All right. Well, if you're interested in this, there's an article for you to read. It's just published this year. AI and statistics perfect together. My good friend Tom Redman and Roger Hurrell were the author. All right. So we can think about how to put those 2 things together. All right. And what example was that can help AI? The right data, not the data right. The simple population randomization model testing, hypothesis testing, and statistical process control. There are a whole lot more I think statistics can contribute. I think we still lots of long way to go to helping AI. All right. I'll skip this theoretical base and database. I think both are important. Theoretical base is foundation to make sure you know what you're doing. Well, database, it gives an empirical observation, which is also important. For example, if you try to cure a very specific cancer, you know exactly what problem you have. And theoretical approach will be ideal. On the other hand, you want early detection of any potential disease, then database may be more appropriate. Okay? AI apparently is more database than theoretical base. Nothing wrong with it. I think both are important in many ways. Right? I don't think I have time for this, but let me say a few words about this. When you fit a model, especially in statistical training, you need to worry about whether 3 cases. Model is correct, okay, that'll be ideal. And that's what we learn in classroom. Model is correct, and then I do all kinds of things, statistical inference about it. But you also need to think about what if the true model is too small, smaller than the model you're using. Or the true model is much bigger than the model you're using. Think about those 2 cases. Statistics study this, and they tell you when model is correct, your estimation, your prediction will be unbiased, and your variance will be small. When model is too small, your prediction will be wrong. Okay, so that's not recommended. When model is too large, statistical theory tells you your prediction will be unbiased, but your variance will go crazy large, right? So that come to different concept about model building statistic in computer scientists. Computer science seems like a model a little bit more overfitting because the prediction will be good anyway. But statistics like to use simple model. So that's fundamental difference between those two. And different discipline may have different interpretation to this. But fundamentally, the idea is very different. Statistics, besides efficiency, we need simplicity. But for computer scientists, efficiency is important, and complicated model is nothing wrong with complicated model. The more complicated it is, more likely to be true. All right. The fact is, AI will be more and more powerful. Will AI be more and more powerful? Absolutely. Nothing wrong with that. And I personally think that will be the case. I strongly believe that. But will AI replace BI? I don't think so, because lots of things we don't understand about BI. And we need lots of work to understand it. All right. I'll skip this. So the bottom line is, how can human beings, you and I, use AI, BI, and SI together to do things better? All right. When AI gets stronger and stronger, BI, so we can find more and more BI, and maybe with some statistical inference, we can make life much easier and correct. Okay. One more comment I'd like to make before I sign off. The truth is stranger than the fiction, because the fiction must make sense. It's the same thing for AI. AI must make sense. Okay. So let me try to get a solid example. When I was a young kid, we will learn Chinese history came from Yellow River, and they find on the top of Yellow River, they found some pottery about 5,000 years ago. They discovered that. Okay, about years ago, about 60, 70 years ago, they find something from Sichuan. They discovered the golden mask, which is much high-tech technology than pottery. They find out was 6,500 years ago. So meaning everything I learned from about Chinese culture is wrong because the input data was incorrect. Now we are in trouble to find out what's really true Chinese history then. AI, I worry. If input data is not quite right, they can collapse overnight. Okay? So fundamentals are always important. They cannot be done by AI, especially from people from College of Science. I think AI will be stronger and stronger, more and more powerful, no doubt. We should make use of AI. But there are lots of things AI cannot replace. Okay? One more thing is more like a April announcement. The thing run AI is very energy consuming, right? You need lots of, Taiwan is very strong, but Taiwan electricity power is weak, and therefore they cannot do good AI at all. It's unfortunate, right? Where running BI is free. If you ask a monkey, probably half banana will show good enough, right? But AI is really. All right. So this is what I give. I've got about a few minutes. This is what I give in my Deming lectures. AI, data science, statistics. For those reasons, I'll be happy to share those slides with you. Why statistics need data science? We just need each other. We're not excluding set. Okay. Again, I repeat what I told you at the beginning. There are so many people in the world. Did you marry Mr. Right? There are so many data in the world. Did you find the right data? To marry Mr. Right, you need strategy. To find right data, you need statistics. Okay. I myself contribute quite a bit on digital twins. If interesting, we can talk about that. So let me conclude. Come to my conclusion. My good friend Jerry Hahn, retired, and Roger Hurrell say this golden age for statistics, but not necessarily for statistician. Many people believe they know statistics. They just go. Hopefully today's lecture will give you some basic idea about what common, very simple, straightforward, fundamental things misunderstood by other people. So what do you see? The crisis, the word crisis in Chinese means dangerous, also means opportunity. In the same word. And it depends on what you see there. This could be dangerous for statistics, but this could be a good opportunity for statistics. Okay? So they were joking about the full stage in your life. First stage, you don't know what you don't know. When you're a teenager, you don't know what you don't know. Everything is possible. When you're about 30 years old, you know what you know. Now you're more focused now. When you're about 40 years old, you know what you don't know. Many things you should think that's good.
Almost
It's not-
65.
You don't know what you know.
What was that? And in last stage, in my age, about retire, we don't know what you know. Right? You're getting wise now. So my point is, AI still in phase 1. They don't know what they don't know. Well, Dr. Ling, me, is in phase 4 now. I don't know lots of things. I know now. So this is my abstract. I want to share with you 2 sentences over there. Not so informative input will result in not so intelligent AI. And the bottom, I tell you, how can humans use AI, BI, and SI together to do things better? That's what I'm hoping we can learn together. AI people is very strong, and I admire that, but they cannot replace lots of things. So let me jump to my conclusion. Bus moves slowly, and the man try to catch the bus. The lady on last row in the bus say, "Hey, you can't catch it." The man say, "I have to catch the bus." The lady say, "There will be another bus coming in a few minutes. Forget about this one." The gentleman say, "I must be there because I'm the driver." The point I try to make, if data science is a moving bus, we supposed to be the driver, and we are not even in the bus yet, right? So statisticians should stand up, speak loud, that people know there are lots of things SI can help, and hope you can help speak loud and then other people knows, all right? If you have any question at all, I think I run out of my time. So here's my contact information, my family, my dog, my grandson, my husky, and my DKJ link at Purdue.edu if you have any comment at all. Thank you very much.
So let's thank Professor Lin for a great presentation. Maybe there is time for one question. Anybody? Yes, go ahead.
I was curious, like, looking back over, like, you mentioned, like, AI to artificial neural networks to Internet of Things, sort of back to AI. Has there always sort of been this impulse from people in those fields to think of it as like, we're finally going to replace biological intelligence, or is that more of a new thing?
Can anybody repeat the question for me?
Yeah, so the question is about artificial intelligence being always, if there has always been the idea of people in artificial intelligence to be able to replace biological intelligence.
Well, I'm not particular expert in AI, but my understanding, AI from very beginning, back to Turing, 50s, 60s, what they're trying to do is follow logic base. If you learn mathematics, if P, then Q, if non-Q, then non-P, and so forth. Those try to give some common sense, but that doesn't work out because in many cases, every logic has some exception, right? So they starting with database. If people buy B also buy diaper with probability, with what they call confidence, 80%, they can rule that, not 100%. If 100% become theoretical base, logic base, but lots of things is 90%, 80%. So from data, they move from logic base to database. All of a sudden, AI just boom up. They do wonderful job. So I do think people from very beginning, my personal understanding, the very beginning, AI tried to learn from logic base. And I'm not sure that answers the question, but that's my 2 cents I can contribute.
Well done. So I think we took enough time from Professor Lin. So let's thank Professor Lin again for the great presentation.
Thank you very much. You're welcome to send me an email at dkjling@purdue.edu if you got any comment or anything you want to discuss. Thank you so much, and wish the conference, the workshop go very, very successful.
Thank you very much, and we start again with the activities of the Science Week tomorrow.
Sure. Okay.
So thank you. Bye.
Okay, bye.
Thank you very much, everybody. So let me post this one. Something which is not working completely right. For example, in this moment here, now I don't see anything anymore. And so I don't know exactly if, okay, I can stop it from here. No, I can't stop it from here. Why can't I stop it? See what I'm talking about? That I don't see anymore there.
I don't. No, it's not there.
Mm.